Alright, so today you're learning about volumes of pyramids and cones. If you take a look at this picture right here, we have a triangular prism. And what you can do is you can actually split it up into three congruent triangular pyramids. So this actually helps us get our formula for volume of pyramids and cones. The volume is similar to that of a prism. However, the only thing we're changing is that we're adding a 1/3. So the volume is 1/3 base area times height of your prism. So big B stands for base area. Okay, and that changes based on what type of shape your base is. Okay, so it's always important that you look at the base of your pyramid and recognize what it is and how to find the area. And then H is the height of the prism. Excuse me, height of the pyramid or cone, not prism. Alright, so example 1, finding the volume of a pyramid. Okay? First thing we need to do is get our base area. Okay? We know that it's a triangle, and to get the area of a triangle, it's 1/2 little b. Excuse me. 1/2 little b means the base of your triangle times the height of your triangle. Okay, so I have this triangle here, and I see that this is 4 and that this is 6. 4 is going to go in for little b, 6 is going to go in for little h. So my base area is going to be 1/2 6 times 4. So 6 times 4 is 24, divided by 2 is 12. Okay, so we know that big B is 12. Okay, then we have to look at our pyramid. Now, we do not want slant height. Okay, slant height, I kind of think of someone sliding down a slide. Okay, that's what slant height would be. Okay, we want the true height, and the true height goes from the center of our pyramid, okay, at the top of the pyramid, directly perpendicular to the base of our pyramid. Okay, so in this case we have 9, so the height of our pyramid is 9. So we actually have everything we need to plug in to our formula. Volume is equal to 1/3 base area, which is 12, times the height of our pyramid, which is 9. So we get 12 times 9 divided by 3, which is 36. And take a look at your units. Since we're talking about volume, this is going to be meters cubed. Okay, so anytime you're dealing with volume, your units have to be cubed. Alright, let's talk about the volume of a cone. Okay, so same concept, V equals 1/3 base area times height. But if you think about the base of a cone, it's in the shape of a circle, and we know the area of a circle is pi r squared. So what we're going to do is we're going to plug that in for big B to get volume is equal to 1/3 pi r squared h. And this is for a cone. Okay, volume of a cone. So let's try an example. It says find the volume of the cone. Alright, so volume is equal to 1/3 pi r squared h. Okay, h stands for the height of the cone, which we see is 4.5, and we need the radius of our cone, and we see that's 2.2, so we're going to plug that in for r. And we actually already have everything we need to plug in. So volume is equal to 1/3 pi radius, which is 2.2 squared, times the height of our cone, which is 4.5. Okay, if you plug all of that in, you should get, let's see, 7.26 pi, or if you actually multiply by pi, it's about 22.81 centimeters. And then remember, it's volume, so it has to be cubed. Alright, next example. It says using volumes of pyramids and cones. Originally, this pyramid had a height of 144 meters and a volume of about 2,218,800 cubic meters. Find the side length of the squared base. Okay, so we know that the base area is going to be side squared because it's a square, right? Okay, so we're going to keep that in mind. We also know that the height is 144 meters. And then we also know that our volume is 2,218,800 meters cubed. Okay, so we have three pieces of information. Well, I know that I need to write down my formula. Okay, so volume is equal to 1/3 big B times H. And in this case, and we know that we need big B to represent the base area, so I'm just going to plug in side squared. We know that the volume is this $2 million, not $2 million, 2 million meters cubed. We're going to plug that in for B. So 2,218,800 is equal to 1/3 side squared times our height, which is 144. Okay, so I'm actually going to go ahead and take 144 times 1/3, which is 48. So I'm just going to erase that so I have some room. So we get 48s squared. We need to get s by itself, so we're going to divide by 48 on both sides. And s squared is going to equal, which is 46,225. And to get rid of a square, you have to square root both sides. And we get our side to be 215. So 215 meters. Okay, and this is just a linear dimension, so your meters just have to be meters. You don't have to have square or cubed or anything. Alright, example 4. Let's talk about changing the dimensions of a solid. Describe how multiplying all linear dimensions by 1/3 affects the volume of the rectangular pyramid. Alright, so here's a quick trick if you haven't learned this already. I taught my kids this thing called PAB 1, 2, 3. And what this represents, it talks about the effects of the changing dimensions. If you look at your perimeter and you have some scale factor, it's going to be your scale factor just the way it is. So in this case, if I were to change the dimensions, my perimeter would be multiplied by 1/3. Okay. If I'm asking about the changing dimensions on my area, it's going to be my scale factor squared. So if I would take 1/3, I would square that, and I would get 1 squared over 3 squared, which is 1/9. So my area would be multiplied by 1/9. And then the volume is the scale factor cubed. So you would take whatever you're multiplying your sides by, cube it, which is 1 cubed over 3 cubed, which is 1/27. Okay, so the volume will be multiplied by 1/27, or decreased by 1/27. Now, what you can do is you can look at your dimensions before the change. Okay, we know that our slant height is 9. We know that our we know our length is 9, we know our width is 6, and we know our real height is 18. So if you find the volume of that pyramid, which is 1/3 base area times height, so you just take 1/3 times 9 times 6 times 18, and you get 324 meters cubed. Well, if you take each of those dimensions and you multiply them by 1/3, okay, essentially that's just 9 divided by 3. You get 6 divided by 3, and then you get 18 divided by 3 to get our new dimensions of 3, 2, and 6. Then you're going to plug it into your volume formula again, which is 1/3 base area times height. Plug in your new dimensions, which is 1/3 3 times 2 times 6, and you end up getting 12. Well, for your scale factor, you take new divided by old. Okay, your new volume was 12. Your old volume was 324, and if you actually plug that into the calculator, guess what it ends up being? Your scale factor ends up being 1/27th. Okay, so if you like finding the volume and comparing new over old, then do that. If you understand this PAV 1, 2, 3 thing, do that. It's just a quick, simple trick, so that way you don't have to do the new over old every time. Alright, so example 5. Describe how doubling the height affects the volume of the cone. Now, on this one, you can't actually use the PAV one because we're not actually changing both dimensions. We're only changing one of them. Okay, so this one you actually need to look at your dimensions. Okay, so our old dimensions, our radius is 3 and our height is 5. So if you take the volume, which is going to be 1/3 pi r squared h, okay, we know what our r is, which is 3. We know that our height is 5, so we're going to plug that into the formula for 1/3 pi 3 squared times 5, and when you plug that into your calculator, you end up getting 15 pi feet cubed, which is approximately 47 feet cubed. Okay, but we're going to leave it in terms of pi, and I'll show you why in just a second. Okay. Alright, so after the change, if you take the height and you double it, your new dimension for your height is going to be 10, and your radius stays the same, it's still going to be 3. Okay, so plug it into the same formula, 1/3 pi r squared h. For r, you're going to put in 3, for h, you're going to put in 10, and you end up getting 30 pi feet cubed, which is approximately 94 feet cubed. Now, for your scale factor, to figure out what it was, you take your new divided by your old. Okay, so we have 94 divided by 47. If you actually divide that, you get 2, which worked in this case because I actually rounded correctly. Sometimes you might get a decimal because these are just approximations. If you take a look at the new, which is 30 pi, and your old, which is 15 pi, well, the pi's end up canceling out, and you get 30 divided by 15, which is 2. Okay, so the volume is doubled. Okay, and that's what the effect is. Alright, last example, it says find the volume of the composite solid. Okay, so to get the total volume, you're going to have to take the volume of the pyramid and you're going to have to add it to the volume of the prism. Okay, well, you have to think about your volume formulas. So volume total is going to be equal to the volume of the pyramid is 1/3 base area times height, plus the volume of the prism is going to be base area times the height of that prism. Okay, this one should be pretty easy because you just take 6 times 6 times 6, okay, for your base or your volume of the prism. Okay, so 6 times 6 times 6, and then for your base area of your pyramid, okay, I'm shading it in for you, it's parallel to the bottom of your prism, so you can actually use 6 and 6 for this base as well, and then the height of the pyramid is 6 again. So we are going to plug in 1/3 base area is 6 times 6. And then we have our height of our pyramid, which is 6. Plus, we have length times width times height of our prism. And so when we actually plug those all in, you get 288 meters cubed. And if y'all don't like the way this looks, you can actually write this as 6 cubed plus 6 cubed, because it's 6 multiplied 3 times by itself. So 6 cubed. And that does it for volume of pyramids and cones.